Hi students, welcome to our YouTube channel again. So today we will discuss walk through A-level AQA GCSE Chemistry 2020 paper. Okay, so here that paper is regarding A-level Chemistry paper 1 in Organic and Physical Chemistry. The year is 2020. Okay, so now we are going to start question number 1. This question is about enthalpy change. So question number 1.1 is Fig 1 shows a Born-Haber cycle for the formation of strontium chloride. The formula is SrCl2. Okay, so here the Fig 1 shows in which there are the different levels like atomization, first ionization energy, second ionization energy, electron affinity, and and the lattice energy as well. So and the table is also given, so you can see that there are the different energies that are present here. Okay, now the question is use the data in the table 1 to calculate the value of electron affinity of chlorine. Okay, so that is 3 marks question. It means that you have to write the first the equation, the formula in which del HF is equal to all the energies, and then you have to put the values, and then the next one you have to find the electron affinity of the chlorine atom. So then you can write here. Okay, we will start. So first of all, I am going to take this table from here and I am going to paste here. Then we will see that at which level what happened and what's that energy will be. Okay, now first of all you can see here Sr is converted from solid to gaseous. It means that is the atomization of strontium. So here we will you can see here the first the enthalpy of the atomization of strontium. So it means here you can write plus 164. Okay, then that is the second one case. Here you can see again now the chlorine Cl2 in that is present in the gaseous form, so that is converted into 2Cl. It means now the chlorine molecule will convert it into atomic form. So here the enthalpy of atomization of chlorine, so that is 121. So here I am going to write plus 121. Okay, and the third one you can see now the strontium Sr atom will be converted into ion. So here one electron loss from the strontium atom, it means that is the first ionization energy of the strontium, that is 548. So here I am going to write plus 548. Okay, now we need to check the second ionization energy because here Sr positive will convert it into Sr positive 2, and here the another atom that will be lost. So here we can use the second ionization energy, that is 1060. Alright, now the next one, here the 2 chlorine atom will gain the 2 electron, it will convert it into 2 chloride ion. So actually that is the electron affinity that we have to find. So here let's suppose we are going to write X. Okay, that is unknown, so we have to find it. Okay, now you can see a downward arrow, it means now that will be negative. So strontium ion and chloride ion will combine to form SrCl2. So it means here is what? The lattice formation of strontium chloride. It means that is the lattice energy. So that equal to minus 2, 1, 1, 2. Okay, while the enthalpy of the formation of strontium chloride is minus 828. So here you can write minus 828. Okay, now we will see the formula So that will be del HF. I am going to write del HF, like the enthalpy of the formation is equal to del AH of SR. Here I am going to write plus, and there are the two chlorine atoms, so it means 2 into del A H for chlorine, and then plus first ionization energy, so del first ionization energy, okay, enthalpy that is of SR, and now again there will be second plus del second IE H, that is related to SR, okay. So I am going to not I will not write here, okay. Next plus, now here is you have to find the electron affinity. So there are the two chlorine atoms, so it means there will be 2, and I am going to write like for the electron affinity, let's suppose that is X, because we are going to find it, that is unknown. And the last one, that is again the lattice energy, so del LE H, okay. Now we are going to put the values. So as we know that del HF we already did, that is minus, like that is given in the table as well, so minus 828 plus, sorry, is equal to atomization of strontium, that equal to 164 plus 2 into chlorine, so it means there will be 2 times 121, that is the atomization of the chlorine. And then the next one, first ionization energy, so that will equal to 548. The second ionization energy, that will be approximately to its double, like that is closer to, because that is higher, so here is 1060, that is already given in the table. And now here is the second, like the enthalpy of like the electron affinity, that is unknown. I am going to write plus 2x because we have to find it. And then the last one, that is the lattice energy is minus 2112, okay. So when we calculated that, the whole, so that will equal to, let me close it, okay. Now you can see these are the values. So when we calculate it, so then that will equal to 2x is equal to minus 3, 2x is equal to, when you calculated it, so then that equal to minus 730. So as you can see here, 2x is equal to minus 730, so it means x will equal to minus 365. So it means your answer will be 365, that will be minus. So it means the electron affinity of chlorine atom, that is for one atom, okay. For the two atom, that will be equal to minus 730, but you have to find for one atom, that is minus 365 kilojoule per mole. So that is the answer of your first question. Okay, now 1.2, draw a line from each substance to the enthalpy of the lattice formation of that substances. So that is 1 mark question. So it means you have to like draw the lines. So as we know that these data are already calculated, and we need to remember these data and the values as well. Okay, for example, the magnesium chloride, the lattice formation of, like the enthalpy of lattice formation of magnesium chloride, that is minus 2493. So here I am going to write, like I am going to put that arrow. Now the next one, magnesium oxide, So that is minus 3889, while barium chloride will be minus 2018. Okay. Now the third question, that is for part 1, question number 1. Okay. So table 2 shows the theoretical lattice enthalpy based on the perfect ionic model and an experimental value for the enthalpy of the lattice formation of silver chloride. You can see here the theoretical is minus 770, while the experimental is like the less than, because that is minus 905. State why there is a difference between theoretical and experimental. Okay, so for which one? That is for the silver chloride. Silver chloride, AgI. Remember that, sorry, not silver iodide, that is silver chloride, AgCl. Okay, remember that the silver chloride, like, that has covalent character, because that is 1 mark question. So here I am going to write that is AgCl has okay covalent AgCl has covalent character, the first one. Okay, and you can say, or you can say that there will be a partial covalent bonding as well as ionic bonding, or you can say that, or like that contain partial covalent bonding. Okay, as well as ionic bonding. So remember that you need to write AgCl has covalent character or partial covalent bonding. So that's why there is a difference between theoretical value and experimental value. Okay. Now the next one, that is 2 marks question. 1.4 table 3 shows the enthalpy of the hydration value for ions of some group 1 element. So you can see here lithium, sodium, potassium. So enthalpy of the hydration, that is minus 519, here is minus 406, and here is minus 322. Why? Explain why the enthalpy of the hydration become less exothermic from lithium to potassium. So first case, as we know that from top to bottom the size of the atom increases. Is it? Like, because you know that the lithium ion has smaller size as compared to potassium ion, or you can say that the charge density of the ion decreases. Okay, so first I am going to write, like I am going to write in a shortcut way, like for example the first one, that is size increases. Now the second case, because that is 2 marks question, so it at least you have to mention the 2 important characteristics. So the first one, that is size increases from top to bottom. Now the second one, that will be the electrostatic attraction between the metal ion, like for example lithium, sodium and potassium, and because that is the enthalpy of the hydration, so it means that is the electrostatic force of attraction between metal ions and oxygen of water. Okay, so here I am going to write the electrostatic, like force of attraction between metal ions and oxygen of water. Okay, oxygen of water decreases. Why? Because you know that the lithium has smaller, the size, due to small size, so it means the outer electron or the outer shell is closer to the nucleus, so there will be a greater force of attraction as compared to potassium. It means that the attraction between the lone pair of oxygen atom and the ion decreases. Okay, so that is the answer. Okay, now question number 1.5 is calcium bromide dissolved in water. Show some enthalpy data. Again, here you need to find the same thing we already did in question like 1.1 as we already did in the 1.1 question. Okay, here is the enthalpy of the solution of calcium bromide that is given, lattice energy is given, enthalpy of the hydration that is given. Use the data in table 4 to calculate the enthalpy of the hydration in kilojoule of bromide ion. So again here that we need to check, there will be the bromide dissolve in the water, so it means here is dissolution, so it means that will be, I am going to write del solution enthalpy del SOLH is equal to del lattice formation of calcium bromide. Okay, so I am going to write LE lattice energy dissociation. Okay, H plus here enthalpy of the hydration of calcium ion, so there will be calcium will be del hydration, I am going to write here is a small h, it means that is like hydration, and here is the enthalpy of calcium ion, so you can mention or not, it's up to you. So here is, I mentioned that calcium ion. Okay, now the next one, that is you need to add the hydration of bromide ion, but you know that when the calcium bromide CaBr2 dissolve in the water, it will produce Ca positive 2 plus 2 bromide ion. So it means that here we need to add 2 into X because we need to find the bromide ion that is not given in the table. Okay, so first of all, the solution is minus 110, you can see here, then is equal to the lattice energy is that will be 2176 plus the hydration that is minus 1650 plus 2x. Okay, so here let me calculate it that. So 2176 okay, so that will equal to 2x is equal to minus 636. So it means x will equal to how much? Minus 380. So it means you can write here minus 318 here. That is kilojoule per mole. Okay, so now we are going to solve question number 2. This question is about the isotopes of chromium. Give the meaning of the term relative atomic mass. So as you know that there are a lot of the definitions regarding relative atomic mass. Like for example, the another name of relative atomic mass is also known as average atomic mass. That is the mass of one atom of an element that will equal to 1/12th mass of one atom of carbon 12, or you can write like more precise definition, that is average mass of element or relative atomic mass. Here I am going to write average mass of atom compared to relative compared relative to carbon 12 on a scale in which an atom of carbon 12 has a mass of 12, has a mass of 12, because that is the 2 marks question, so it means you need to write a more precise definition or more accurate and more valuable definition here. Okay, again 4 marks question, so that is little bit tricky because that is also again like the calculation based. Like a sample of chromium containing the isotopes chromium 50, 52 and 53 has the relative atomic mass that equal to 52.1. So calculate the percent. Okay, the sample contain 86.1% of the 52 chromium isotope. Calculate the percentage abundance of each of the other 2 isotopes. So it means here the given data, that is like you can say here that will be first the percentage of chromium 50 and chromium 53, that equal to how much? First we need to write collectively. Okay, so if you see here the percentage of 52, that is 86.1. So when you subtract 100 minus 86.1, so it means that equal to 13.9%. Okay, so that is collectively percentage of chromium 50 and chromium 53. Now here let's suppose we are going to write the chromium 53 is equal to X percentage, while the chromium 50 that equal to 13.9 minus X percentage. Okay, because here we need to find each of the percentage. So one is X and the other one is 13.9 X. Okay, now as we know that there are the first of all here is like the relative atomic mass that equal to 52.1. So relative atomic mass is equal to 52.1. 52.1 is equal to, now the first, that is chromium 50 equal to 13.9 minus X. Its atomic mass is 50, so here I am going to write 50 times 13.9 minus X. Okay, plus the next one, that is like chromium 52. So 52 that equal to 86 0.1. So here I am going to write 52 into 86.1. While chromium 53, the chromium 53 will equal to 53 into x, because we already suppose that equal to x. Okay, so that is percentage, so it means divided by 100. Okay, so when you calculated that, like when you multiplied 50 times 13.9 minus 50 times x plus 52 times 86.1 plus 53 times x, and 100 will go to the other side, it will be in multiplication, and then the answer will be like 50x, as you can see here, 50x minus 50x plus 53x, it means that will equal to 3x is equal to 37.8. Okay, now what will be the x value? X is equal to 37.8 divided by 3, that will equal to, like here, 37.8 divided by 3, so it means that will equal to 12.6. So here you got one thing, that chromium 53 percentage will equal to 12.6. I am going to write here 12.6. Now we need to find percentage of like chromium 50. So here, as we already mentioned, the chromium 50 will equal to 13.9 minus x. So here we can write 13.9 minus 12.6. So we got like about 1.3. So it means chromium 50 will be 1.3%. So that is your answer. Okay, now the next, state in terms of the number of fundamental particles, like number of fundamental particles, like one similarity and one differences between atoms of chromium 50 and chromium 53. So actually these are the isotopes, and remember that the definition of the isotopes, that has the same number of atoms but different number of, like you can say, but different atomic mass or the mass number. Like sorry, here the isotopes mean they have the same proton number or the same atomic number but different mass number or different number of neutrons. So you can write here, similarity is they have same number of protons. Okay, while the difference, that is like number of neutrons, or you can say here that is the different number of neutrons. In other words, you can write they have same atomic number but different atomic mass or the mass number. Okay, here is the question related to the time of flight mass spectrometer. The sample of the chromium is analyzed in the time of flight mass spectrometer. Give two reasons why it is necessary to ionize the isotope of chromium before they can be analyzed in a time of flight mass spectrometer. So here are the different reasons, but you have to write the two important reasons. So the first one, as you know that the chromium is analyzed, so first the chromium will convert it into ionic form, because here in like why the chromium, it is necessary to ionize the isotope. It means why we need to convert the isotope into ionic form, because ions will interact with and accelerated by electric field. Okay, because here the ions will interact and accelerated Why it accelerated? By an electric field. Because you know that now they contain like a charges, so that's why these are now converted into charged particles, so they can be easily accelerated by the electric field. The second reason why it is necessary to ionize, the second reason is ion create a current when strike with the detector, like create create a current when hit with the hitting the detector or strike with detector. And another name of detector is like electron multiplier. Alright, so that is the answer of 2.4. Okay, now the next question is 2.5. Here is the chromium ion 53 is the mass number, travels along a flight tube of a length is 1.25 meter. The ion has the constant kinetic energy is given 1.102, and the formula is also given. So here the formula kinetic energy is equal to mv square divided by 2 or half mv square. So that m is the mass of ion per kg, remember that, while the v is the speed of ion per meter per second. Calculate the time in seconds for the 53 chromium ion to travel down the flight tube to reach the detector, and the Avogadro's constant is also present. Okay, so here are the two formulas in which we can use and we can detect that there are the two ways in which we can find the time. The first formula, that is like V is equal to d over t. Okay, that is the first formula. We can use that and we can easily calculate the time. While the second formula, that will be the like related to kinetic energy. So kinetic energy will equal to, I am going to show you with different color. Kinetic energy is equal to m d square divided by 2t square. So these are the two formulas we can use and we can like easily calculate it, the time. Okay, first of all, you can see here velocity and here is the mass. In both cases we need to find like both species, like velocity and the speed and as well as the mass. Okay, first, like for example here, what will be the mass here? Mass of ion per kg. So it means we need to find first mass of ion. Mass of ions. So mass of ion will be equal to, as you can see here, 53. 53 is actually, that is what? Per kg, it means you have to divide it by 1000. That will equal to like 53 divided by 1000. So that will equal to 0.053. Now you need to okay, so now you need to divide that by Avogadro's number to get the mass of ion. Okay, so that will equal to 8.8 times 10 to power negative 26 kg. Okay, that is the mass of ion. Okay, now like we can easily solve it. Like for example, if we use the second formula, that is okay, this like the first formula, like for example the formula that is given, kinetic energy is equal to mv square divided by 2. So first you can write, you can rearrange, that will equal to 2 into kinetic energy is equal to v square, and m will be divided here. Okay, so that will equal to like 2 into 1 point, how much, 1.102 times 10 to power negative 13. Okay, 1.102 times 10 to power negative 13 over the mass will equal to 8.8 times 10 to negative 26. That is equal to v square. So it means taking square root on both sides after calculation. So that will equal to v is equal to like 1.58 times 10 to power 6 meter per second. Okay, that is the value of v. So now we can easily like put the value of v here. Like we already know, that is v is equal to d over t, and t will equal to d over v. So d is equal to, that is given 1.25. So here is like 1.25 divided by the v, that is 1.58 times 10 to power 6. Okay, so that will equal to 7.9 okay 7.9 times 10 to negative 7. Okay, that is in second. So it means that is the first answer. Like you can easily find out, and that will be, you can write here like 7.9 times 10 to negative 7. Okay, or the another way, for example, if you use the another way, that is kinetic energy is equal to md square divided by 2t square. So here you can rearrange. First I will solve that like way as well. So t square is equal to md square divided by 2 ke. So here t square is equal to the mass, that is 8.8 times 10 to power minus 26 times 1 point, the d square is 1.25, and that will be in square form, divided by 2 into the kinetic energy will be 1.102 times 10 to power negative 13. So as we already knew. So when we calculate it, and here is t square, it means you have to take like the square root on both sides. Okay, so t will equal to, again it will give the same answer. Or for example, I am going to solve it first. So that will equal to, t square will equal to 6.24 times 10 to negative 13. If you take square root on both sides, so T will equal to again 7.9 times 10 to negative 7. Okay, so in second. So here in both cases you can get the same answer. Alright, so that is the end of your question number 2 here. So in the next part we will proceed question number 3. So will join us in the next video. So then we will start the next part. Okay students, so take care. We'll see you in the next video. If you like our video, so then kindly subscribe our channel and share that content with your families and friends. So take care a lot and we'll see you in the next video. Goodbye.